Keeping the energy up. Nice. All right, so we already did a who uses Ollama, but I kind of want to see it again just so I know how deep to go into. Who knows Ollama and uses Ollama? Okay, we have some people. So I'll still run through like the generic, who are we and what do we do? And so we'll get started there. So Ollama is pretty simple. We run large language models very simply. It is super, super easy to run them. And often people will run them on their laptops. So even earlier we had the great Granite talk. That Granite model is available on Ollama as well. And you can search for various different models through here. I hope it is visible. And you can kind of see and use whatever fits your model. And so just to give a quick run through of what Ollama run looks like, we can just do Ollama run DeepSeek R1. So this is actually a distilled version of DeepSeek, I believe on Qwen. Just to give you guys an example of what it looks like. So I can just say, hi, and it thinks, right? We can ask it 2 + 2, but we also don't want to be here forever, so I will tell it, don't overthink. And so clearly thinking a lot. I like to think of it as a Gen Z who is very anxious about what it's thinking. And there we go. It has put out 4 as expected. All right. So one of the things I'm talking about today is, well, this is cool and all, but how do we actually make use of this? One of my favorite uses for large language models is going from data, which makes no sense, where you can write regex for hours and you cannot get the data you want, to data that is clean and outputted nicely. So that's kind of what we're going to be covering. We can dive right into the code. So over here, very simple. If you haven't used Pydantic before or our Ollama Python package, we're making use of both over here. And so I'm doing a couple things. The first thing I'm doing is defining a friend info class in which I have name, age, and if that person is available. And over here, we have friend list. So this is just a list of friends. So in this case, I am passing this content, which is I have 2 friends. Is it visible for everyone, by the way? Good? Sick. I have 2 friends. The first is Ollama, 22 years old, busy saving the world. And the second is Alonzo, 23 years old, and wants to hang out. Return a list of friends in JSON format. So usually, you'd actually want to pass in the schema as well for better performance. But in this case, I have not done that. So let's actually run this and see what the LLM spits out. Great. So that was pretty quick. I can check what model I was using. So it was just the Llama 318B. And you can actually see that it returns this very well-structured object from just a string I decided to pass in, where it says, is able to pull out that friend information that I was looking for. And so you can extend this to whatever use case that you can think of, whether it's going from random receipts, random data, to something, a structure in a JSON or within your Python or TypeScript as objects. And one of my favorite things about this is that it actually works for images as well. So over here, we have defined another couple objects for images instead. So over here, I have a class object, and I also have image description. So essentially, I'm just showing that it can be nested as well. And so over here, we can have objects, and I've just passed in a couple images, or 1 image actually. So I have this beautiful sunset, which I believe is from Palo Alto, obviously. And I'm using Llama 3.2 Vision in this case. And so all I've said is analyze this image and return a detailed JSON with a little bit of this information. And then we also set temperature to 0 to have a bit more deterministic output. And all I'm doing later on is putting that JSON back into a Pydantic object. So let's run this. This one takes a little bit more time, obviously, because it's a bigger model doing the entire image portion of the model as well. And I will try and keep talking while this runs, so it's not awkward at all. And we are still waiting. It is running locally on my Mac, so that is pretty cool. But we are still waiting. All right, taking a bit today. OK, there we go. So actually, I forgot to save it, and we got Kachao instead. So we actually passed in this image. And what we got was a red race car, racetrack, red afternoon, and the setting is outdoor. And all of those things are pretty accurate. And this is really cool considering it's a pretty small model. And let's actually do it with the sunset now. I'm going to run the same thing. I just saved my file. It's going to take another second, a few of those seconds. Doing is I've only taken like a very small portion of the entire workflow. But the first thing that the model is really doing is a forward pass. This is where it's taking in all the information that it has and then coming up with a set of logits. What are logits? They're essentially probabilities or unnormalized probabilities which map to different tokens in the model's vocabulary. So this can be things like A, B, C, but it can also be full words like name, banana, I don't know, like anything really that the model's vocabulary has trained out to be. And so what really happens is the model will go through this forward pass, will give you these logits, and then there's a sampling process where it's looking at distribution, at the probability distribution from those logits, and then picking a token. So in this case, it picked token 2. Now, in structured outputs, this entire process looks a little bit different. So we have our model's forward pass. We get those same logits. But while we're also doing these things, there's something we also need to do, which is we pass in a JSON defining the structure of the output that we need back. And so in this case, just very simple, name, age, and if they're available, very similar to the Python example that I showed. And this is what is essentially creating, OK, let me look at the JSON, and let me see how we can use that to work with the LLM. So what state-of-the-art sampling methods we'll use is essentially a state machine. We're currently using a rules engine, and one of the new ones that I'm working on is going to be using push-down automata, which are also state machines, and that's kind of more on par with state-of-the-art performance in terms of both accuracy as well as speed. But essentially what the rules engine or the state machine are doing is you have like your entire list of probabilities, but not all of them fit your schema, right? Like if I have a JSON and I don't see this open curly brace first, I don't want any other token to be coming back. So essentially what's happening is we do something called masking of the logits. And so after it's gone through the state machine, we come up with another, essentially a mask to go over and say which tokens are valid or not. So this is barring probability. Just tell me what is good and bad. And so what essentially ends up happening is you get a bunch of invalids. So in this case, only token 1 has like a positive probability or like a has a probability in this case. And then we, again, do sampling, and then we get the token 1 back in this case. So you can kind of think in that similar fashion. The way that Ollama is doing structured outputs is also the same, where we are computing this mask and figuring out which tokens are valid and which tokens are not. And then we kind of go through that entire process of generating a JSON, which is what's being sent back and forth. So there we go. Our sunset, which was over here. Goodbye, Lightning McQueen. So beautiful sunset. And we can see that it's described pretty well by our 11B model in total, which is, it says it's a sunset, orange sky with yellow hues, hills, trees. And, it's even describing the scene. Very, very nice. And yeah, that's kind of the main use of structured outputs. If you're interested in Ollama, Ollama.com is where you go, and you can get up and running really, really easily. I'll be there in a second. And essentially, there's a few different things you can also check out. So we have our main repository if you would like to contribute or just kind of follow along. And then for more so using Ollama, we have a JavaScript library. We have a Python library. And we're also OpenAI compatible, so you can just change up and say that you want to point to Ollama, and it'll just work. And if none of those things work, you can add me on GitHub, and I will try and fix it. Cool. All right, we can go for questions now.
All right, let me bring Mike. Thank you, Parth.
I think someone over there had a question.
Hi, so I did a project literally yesterday on a hackathon on GitHub because I knew Ollama, but the very basic functionality that I saw like on the quick start part, and I used it. It went well. I actually did a nice project, but the thing is, it worked really slowly for me, and I didn't realize I could do structured outputs. And all of this looks really good, but I couldn't find the docs for some reasons. So
I'll just point you to it. So if you're using the Python package, you just go under examples, and then we have structured outputs. So
thank you.
Right there. Yeah.
So it's and the other thing, how do you make it go so fast? Because I'm using really light models in this computer.
Yeah,
and,
this computer is a little bit bigger than that. This is just a really beefy Mac, but in general, what I recommend, like having gone through this a bit, is just one, get a cloud instance and deploy Ollama.
Sorry, what?
Get a cloud instance and deploy with like a GPU, or you just have to use a smaller model, or a different kind of quantization. So there's varying.
I mean, I'm using actually the 1.5 million.
All right.
So it's
very small already.
And this is not a light computer. This is beefy. So it might be going way too slow even for like.
Yeah, that is interesting.
So maybe it's a GPU thing. This is not using GPU.
We can check that.
Thank you.
Yeah.
Other questions besides tech support?
It's all good. That's like half my job.
Did you try restarting your computer?
Hi. For the structured output, is that something that's dependent on the model, or does it always work? Does it vary in performance?
Yeah, the performance is a bit dependent on the model size. So bigger models perform much better just because of how many neurons essentially exist in the model, and they're able to make better predictions. And that's really what's happening at the background anyways. Like the model's still picking token by token. What we're doing is saying what tokens can they pick or not. And for Ollama, you can use any model with structured output. So as I showed you, like we used a text-based model as well as a vision model. Now, with reasoning models, it's a little bit different because they have to go through this like think process. The hack around it for now is you do one request where you get all of the thinking tokens. You grab the thinking tokens, you inject them back, and then you get it to do structured outputs. Cannot guarantee any good mileage, but that's something you can play around with.
Let's do one more question.
Parth, I noticed that you're putting the schema within the structured output definition. Is there an opportunity to go directly to like schema.json to get the schema of a particular domain?
For tools instead of structured outputs?
Yeah.
Actually, we can do kind of that already. If you're using the Python repository, I'll just do a quick example. Where are tools? All right, tools.py. Yeah, actually, you can just pass in the Python function itself, and I have, that's too small. I have parsing, which will kind of take care of that for you. So over here, we have two functions. One is add two numbers and subtract two numbers. Very usual examples. And over here, you can see that I just passed in the function itself into tools. So the Python library deals with that for you.
Can I reference that in my structured output definition?
So this is for tools, and structured outputs is a little bit different. In structured outputs, what is happening is you can define these pydantic objects, and you're just dumping the schema.
You see the schema line that you have there? My question was.
Oh, this?
Yeah, the schema line, can it be a web URI that I can reference a schema?
Oh, I've not tried that. I'm not sure.
You could just go to the web, load that schema, and put it
No,
there.
because sometimes the domain schemas are really big.
Yeah, so if it is really big, I usually say that it impacts the performance just because of how many tokens you're stuffing into the context. And it really just varies on how much context size you've allocated.
Well, thank you very much, Parth.